In the name of God. Sophia's Programming Journey. Rolling the Dice, a visual guide to board game mechanics. These are the topics that we are going to talk about. Introduction. What is random? The roll dice function. Printing the board. Customizing the board. Using the dice in games. Advanced techniques. Random number generation. Seeding the random number generator. Generating random sequences. Shuffling sequences. Random sampling. Generating random values. Using randomness in machine learning. Randomness in data analysis. Randomness in gaming. Randomness in cryptography. Randomness in simulation. Randomness in music. Conclusion. Additional resources. Question and answer. Thank you. Contact information. Introduction. Welcome to the world of dice rolling and Python's random library. Have you ever wondered how games like Dungeons and Dragons generate random numbers for dice rolls? Or how online casinos ensure fairness in their games? The answer lies in the power of randomness, and Python's random library is a versatile tool for generating random numbers and sequences. In this presentation, we'll explore the many uses of the random library, from simple dice rolling functions to advanced techniques for machine learning and cryptography. But don't worry if you're new to programming or unfamiliar with these concepts. We'll explain everything in clear and concise language, and use plenty of visuals to keep things engaging and easy to understand. What is random? The random library in Python is a module that allows for the generation of random numbers. This library can be used in a variety of applications, including games, simulations, and cryptography. The roll dice function. The roll dice function is a powerful tool for generating random numbers in Python. It takes two arguments, the number of dice to roll and the number of sides each die has. For example, roll dice 2, 6 would simulate rolling two 6-sided dice. The function returns a list of the results, which can be used in your code however you need. Printing the board. The print board function is a useful tool for displaying game boards or other types of grids in Python. It takes an input grid and prints it out in a visually appealing way, with borders and labels for each cell. In addition to its basic functionality, the print board function can be customized in a variety of ways. You can change the size and color of the borders, add background colors to specific cells, and even include images or icons in certain cells. Customizing the board. Customizing the board in Python is a great way to add a personal touch to your games. With just a few lines of code, you can change the size and shape of the board, as well as the colors and images used for the game pieces. For example, you could create a board that looks like a comic book page, with speech bubbles and sound effects. Or you could create a board that represents a specific location, such as a city or a park. The possibilities are endless. Using the dice in games. Rolling dice has been a staple of games for centuries, and with the roll dice function in Python's random library, You can easily incorporate this element of chance into your own game projects. Whether you're creating a simple board game or a complex RPG, the roll dice function can add excitement and unpredictability to your gameplay. For example, imagine you're creating a turn-based strategy game where players roll a die to determine their movement range each turn. With roll dice, you can generate a random number between 1 and 6 to simulate the roll of a standard 6-sided die. You could even use the roundint function within the roll dice function to generate a random number between a custom range, such as 1 and 10, to create a more unique gameplay experience. Advanced techniques. One advanced technique for using the random library in Python is to use the seed function. This allows you to set a specific starting point for your random number generation, which can be useful in situations where you want to generate the same sequence of random numbers multiple times. Another advanced technique is to use the choices function, which allows you to generate a list of random values from a given population with or without replacement. This can be useful in simulations or when creating randomized experiments. Random number generation. Random number generation is a process of producing a sequence of numbers that cannot be reasonably predicted better than by random chance. In Python, the random library provides functions for generating pseudo-random numbers. These numbers can be used for a variety of purposes, such as simulating real-world events or creating randomized datasets for testing and analysis. The random library also allows you to set a seed value for reproducible results. Seeding the random number generator. Seeding the random number generator in Python allows you to generate a specific sequence of random numbers. This is useful when you need to reproduce the same set of random numbers for testing or debugging purposes. To seed the random number generator, you can use a seed function from the random library. The seed value can be any integer value. Once seeded, the random number generator will always produce the same sequence of random numbers. Generating random sequences. Random sequences can be generated in Python using the random library. A sequence is a collection of elements, such as numbers or characters, that are generated randomly according to certain parameters. The random library provides several functions for generating random sequences, including randint, choice, and shuffle. The randint function generates a random integer between two given values, while the choice function selects a random element from a given sequence. The shuffle function shuffles the elements of a sequence in place, creating a new, randomized order. These functions can be used in combination to generate complex, customized sequences for various applications. Shuffling sequences. Shuffling sequences is a common task in programming, and the random library in Python makes it easy. By using the shuffle function, we can randomize the order of elements in a list or other sequence. For example, let's say we have a list of names that we want to shuffle. We can simply import the random library and call the shuffle function on our list. The result will be a randomized order of the names, which can be useful for things like creating randomized teams or selecting a winner from a pool of entries. Random sampling. Random sampling is a technique used to select a subset of data from a larger data set. It can be used for a variety of purposes, such as testing hypotheses or generating representative samples. In Python, the random library provides functions for random sampling. The sample function can be used to randomly select elements from a list or other iterable. The choices function can be used to randomly select multiple elements with replacement. Generating random values. Random values can be generated in Python using the random library. This is useful for a variety of applications, such as generating test data or creating simulations. To generate a random value, you can use the random function from the random library. This function returns a random float between 0 and 1. You can then multiply this value by a range to get a random integer within that range. For example, if you want a random number between 1 and 10, you can multiply the result of random by 10 and add 1. Using randomness in machine learning. Randomness plays a crucial role in machine learning algorithms. It is used to introduce variability into the training process, which can help prevent overfitting and improve generalization. By adding random noise to the data or the model parameters, machine learning algorithms can learn more robust and flexible representations of the underlying patterns in the data. One common technique for introducing randomness in machine learning is dropout regularization. This involves randomly dropping out some of the neurons in a neural network during training, which forces the remaining neurons to learn more robust and diverse features. Another technique is data augmentation, which involves randomly transforming the input data, for example, rotating, scaling, or cropping images, to increase the size and diversity of the training set. Randomness in data analysis. Randomness plays a crucial role in data analysis. In many cases, data sets are too large or complex to analyze exhaustively, so researchers use random sampling to draw conclusions about the whole population. This is especially useful in fields like social science, where it's often impractical to survey every member of a group. By selecting a representative sample of individuals and analyzing their responses, researchers can make inferences about the broader population with a high degree of accuracy. In addition to sampling, randomness can also be used to simulate data sets for testing purposes. For example, researchers might generate synthetic data to test statistical models or algorithms. This allows them to evaluate the performance of these tools under different conditions and identify potential weaknesses or biases. Randomness can also be used to introduce noise into data sets, which can help researchers identify patterns or relationships that might not be apparent otherwise. Randomness in gaming. Randomness plays a crucial role in gaming, whether it's determining the outcome of a dice roll or the probability of drawing a certain card from a deck. The random library in Python can be used to generate these random events, creating a more dynamic and unpredictable gaming experience. For example, in a classic game like Monopoly, the roll of the dice determines how many spaces a player moves on the board. By using the roll dice function from the random library, we can simulate this random event in our Python code. This adds an element of chance and excitement to the game, making each playthrough unique and unpredictable. Randomness in cryptography. Cryptography is the practice of secure communication in the presence of third parties. Randomness plays a crucial role in cryptography as it is used to generate keys and ensure that encrypted messages are secure. In fact, randomness is so important in cryptography that it is often referred to as the fuel that powers encryption algorithms. One common use of randomness in cryptography is in the generation of cryptographic keys. These keys are used to encrypt and decrypt messages, and their security depends on their randomness. If a key is not random enough, it can be easily guessed or brute forced, compromising the security of the encrypted message. Therefore, generating truly random keys is essential for secure communication. Randomness in simulation. Randomness plays a crucial role in simulation, allowing us to model complex systems with unpredictable outcomes. For example, weather forecasting relies heavily on random variables to generate realistic models of atmospheric behavior. By introducing randomness into our simulations, we can account for the inherent uncertainty and variability of real-world phenomena. In addition to weather modeling, randomness is used in a wide range of simulation applications, including financial modeling, traffic flow analysis, and even video game design. In each case, the goal is to create a virtual environment that mimics the behavior of a real-world system, while also allowing for exploration and experimentation. Randomness in music. Randomness has been used in music composition for a long time, but with the advent of digital technology, it has become much easier to integrate randomness into music. One way randomness can be used is by generating random sequences of notes or rhythms, which can then be manipulated and arranged into a musical composition. Another way randomness can be used in music is by incorporating chance elements into live performances. For example, a musician may use a random number generator to determine which notes to play next, or to select from a set of predetermined musical phrases. This can lead to surprising and unique performances that are different every time. Conclusion. In conclusion, we have explored the random library in Python and its various applications. We learned about generating random numbers, sequences, shuffling, sampling, and advanced techniques for using randomness in machine learning, data analysis, gaming, cryptography, simulation, and music composition. We encourage you to try using the random library in your own Python projects. Experiment with different functions and techniques, and see how randomness can enhance your code and add new dimensions to your projects. Additional resources. For those of you who want to continue exploring the random library in Python, we've compiled a list of additional resources for you to check out. These resources include documentation, tutorials, and examples that will help you further your understanding of this powerful library. Some of our favorite resources include the official Python documentation, which provides detailed information on how to use the random library, as well as online tutorials and courses that cover specific use cases and applications. Additionally, there are many open-source projects and code repositories available online that utilize the random library, which can provide valuable insights and inspiration for your own projects. Question and answer. Thank you for listening to my presentation on the random library in Python. I hope you found it informative and engaging. Now, I would love to hear any questions or comments you have about the topic. Whether you want to know more about how randomness can be used in machine learning or music composition, or you have a specific question about one of the functions we covered, please don't hesitate to ask. I'm here to help you understand and use this powerful library in your own projects. Thank you. Thank you for joining me today to learn about the random library in Python. I hope you found this presentation informative and engaging. Please feel free to reach out to me with any questions or feedback you may have. I look forward to hearing from you. Contact information. YouTube channel for those who want to learn programming for game design or anything else. Sophia's programming journey is ready to provide services to you, dear friends. And don't forget to subscribe the channel and like the videos, turn on the bell, and don't forget to leave a comment. We love you so much.